Alright guys, welcome to lesson 9.6. In this lesson we're going to continue learning how to solve equations that have logarithms in them. And today, I think every equation we're going to solve today is going to involve this property where we have two logs that are being added together or two logs that are being subtracted, and we're going to rewrite them as one logarithm. And these are some properties that we saw in a previous lesson. So let's go ahead and take a look at an example. Right, so here's example 1. As you can see, we have two logarithms that are being added together. We want to go ahead and begin by checking our domain, of course, like what we did last time. So we're going to take this one and we're going to set it equal to 0. Actually, it was greater than 0, wasn't it? And then we're going to go ahead and solve. Want to remember that when you divide by a negative, that causes us to reverse the inequality around. And so our domain is x has to be less than 5. So whatever answer we get, it needs to be less than 5. I don't need to check the domain for this log because there's no x in it. All right, so there's our first step. I'll go ahead and write my answer there at the top, just so I can remember that. All right, so now let's get into the new stuff. Notice that we have two logs that are being added together. Now, we're going to use that property that says that when you have two logs that are being added together, you could take the argument of each of the logs and multiply them together, and therefore put them together as one logarithm. So it's going to be 10 minus 2x, and I'm going to put that in parentheses, times 10. And this 10 is going to distribute into the parentheses there. So I end up with 100 minus 20x equals 3. All right. After that, we're ready to go ahead and exponentiate both sides. So I'm going to write each side as a power of 4 because that is my base. That's something we talked about in our last lesson as well. And those, in a sense, cancel each other out and leave me with 100 minus 20x on the left side. And on the right side, we have 4 to the third power, which is 64. And then from there, we just need to do some algebra. So let's get to it here. Double negatives cancel, and we end up with 1.8. And that is, in fact, less than 5, and so that's a good answer that we will keep. All right, so I'm going to go ahead and put up a practice problem for you guys. We'll call this one student practice number 1. Go ahead and pause the video here, give it a try, and see what you get. When you unpause it, you'll see the answer. So here's the answer. The domain is that x needs to be greater than negative 4.5. I got that by setting this argument greater than 0 and solving. Next, after applying the property of combining these logs together by multiplying the 8 with the 2x plus 9, we end up with this expression here. And then after exponentiating both sides, making each side a power of 4, we get this. And then finally, solving for x, we get our answer, negative 4.25, which just barely is greater than negative 4.5, so it is a good answer. All right, let's go ahead and move on to example number 2. This one involves some subtraction. All right, so when it comes to subtraction, we're going to handle it differently. But before we begin, let's check our domains. We have two domains we want to look at this time. We have x plus 5 needs to be greater than 0, and x needs to be greater than 0. I'm going to subtract 5 here, and x needs to be greater than negative 5. So x needs to be greater than negative 5, and it also needs to be greater than 0, but that means we really don't care about this too much, because if x is greater than 0, then it automatically will be greater than negative 5, right? So you can write both if you want to, but I'm going to go ahead and just put for my domain all that we really care about is that x needs to be greater than 0. All right, so now we get to go ahead and move into the property. So the property says that when you have two logs that are being subtracted, you could take their arguments and divide them. And in so doing, you put them together as one logarithm. Just like that. The one that comes first on the left goes on the top. The second one goes on the bottom. All right, and then we're going to go ahead and exponentiate both sides. So these cancel out, and I'm left with x plus 5 over x equals 7. Now we're ready to solve. Okay, so we want to multiply both sides by the denominator. So I'm going to multiply this side by x and this side by x because that cancels the denominators on the left side there. And now I have x equals 7x. The next thing I would want to do is put my x's together. 7x minus 1x is 6x. Division gives me 5/6. And is that greater than 0? Yes, it is. So that's a good answer. All right. Let's go ahead and toss a student practice your way. Go ahead and pause the video and give that one a try. And when you unpause it, you'll see the solution. All right, so here is the solution. The domain is x has to be greater than 0. I get that from this one. This one would give us x needs to be greater than -4. But I don't really care about that one because if x is greater than 0, that automatically takes care of that one too. So really all I care about is that x needs to be greater than 0. Next, using the property, I can do log base 2 of this argument over this argument, and that's where this comes from. And then we can exponentiate both sides, making both sides the power of the base of 2. And that will cancel out the logarithm on the left, leaving us with x plus 4 over x. And on the right, we get 2 to the 4th power, which is 16. And then solving this, multiplying both sides by x and then subtracting x in division gives us our answer, which is in fact greater than 0, so we're good to go. Right, let's go ahead and take a look at number 5, another addition problem, but you'll see why we're doing another one of these. It does have a little something interesting come up along the way. Right. So domain, x needs to be greater than 0 for that one. And for this one, x plus 2 needs to be greater than 0, which means x needs to be greater than -2, but that doesn't really matter because x is greater than 0 is good enough. That's my domain. Next step, since it's addition, this is one where you're going to be multiplying the x times the x plus 2. And we'll distribute that in there. And as a result, we end up with log base 2 of x squared plus 2x equals 3. Next, we're going to exponentiate both sides. We're going to make both sides the power of a base of 2. Just like so. These cancel out, leaving me with x squared plus 2x. And on the right side, we have 8. And this is why I gave you this problem, because we have a special situation here. We have a quadratic equation. I'm going to go ahead and move the 8 over. When you have a quadratic equation, you want to have it equal to 0. And at this point, there are two different ways you could solve this. Okay, method 1 is you could use the quadratic formula. So if you want to go that route, you would do x equals -b plus or minus the square root of b squared minus 4ac all over 2a and simplify it. The benefit to going with that strategy is that it always will give you an answer. The downside is, in my opinion, it's kind of a lot of work, and it's also something that students struggle with sometimes in simplifying it appropriately. So I'm going to go with a different approach. I'm going to go with the factoring approach. which we haven't done in a little while. So let's review how to factor. This is a trinomial. When you have a trinomial, you do box method. So your first term goes in the top left box. Your last term goes in the bottom right box. And our goal here is to find two terms that multiply together to make x squared, which would be x times x, and two numbers that multiply together to make negative 8, which I'm going to guess are 4 and 2. Now, one of them has to be negative. So let's just take a guess here. Let's put the negative on the 2. And then we're going to complete our box. X times 4 is 4x. And negative 2 times x is negative 2x. And we know that we're correct if these two numbers add up to make the middle. Is 4x minus 2x equal to 2x? And the answer is yes. And so we have successfully factored it. I'm going to erase that now. And what we've just found out then is that it factors into x plus 4 and x minus 2. Okay. Now we have a zero product property. That means if this times this equals 0, that means one of these has to equal 0. So we set them both equal 0, and we solve both equations. So in this case, we get x equals negative 4. And in this case, we get x equals 2. So whether you chose to use the quadratic formula or this method, the factoring method, you should end up with negative 4 and 2. Once again, the quadratic formula's benefit is that it always works. It's just that it's a little bit tedious and prone to make some minor calculation errors. Factoring, if you are decent at it, is less work, and it's less likely to make errors. The downside is not every polynomial can be factored, and so you might be trying and realize after about 2 or 3 minutes you've been trying for no reason because it just doesn't work. So that's kind of the downside with factoring. But to the trained eye, you can kind of see it in advance whether it's going to work and not waste your time. But that takes time and practice. So use whatever strategy you prefer, but the answers are negative 4 and 2. Now, before I actually circle those, let me uncircle those real quick because one of them may not be an answer, actually. We need to make sure they're actually in our domain. So let's go ahead and check out our domain here. It has to be greater than 0. And this one is not greater than 0, and therefore this is my only answer. So we got an extraneous solution here. We talked about those last time. I'm going to abbreviate this ES. If you don't think you'll remember what that means, maybe you'll want to write it out, but I'm kind of out of space here. But this is an extraneous solution, which means that it's an answer that you get by doing all the math steps right, but it's actually just not a legal answer to use. So the only answer to this problem is x equals 2. And it is possible, by the way, that both of them are extraneous and you have to throw them both away. But anyway, quadratic formula or factoring, because we had a quadratic expression. So here is your student practice number 3. Go ahead and pause the video here and give this one a try. When you unpause it, I will have the solution up for you. All right, so the answer is x equals 3. Let's back up and find out what to do here. So domain, x needs to be greater than negative 24. We get that by setting this greater than to 0 and solving. Next, we use the property where if we have two logs that are being added together, we can multiply their arguments together, and the end result will be this. The next thing we're going to do is we're going to exponentiate both sides. If I make this a power of 3, and if I make this a power of 3, on this side, the log cancels out and just leave us with this. And this side, 3 to the 4th power is 81. Since this is a quadratic, we do want to subtract the 81 over, which brings us to this. After that, we want to factor. This one's kind of tricky to factor. When you saw the number 81, if you got there, you were probably thinking, well, the only thing I could think of is 9 and 9. And, well, they had a weird one. The weird one they had was 27 and 3. So it's possible maybe you got frustrated and just tried the quadratic formula. And I think even that might have caused some issues because then you're going to run into some big numbers that you're going to have to multiply together. But in any event, this is how it factors anyway. Setting this side equal to 0, you get negative 27, and setting this side equal to 0 gives you 3. Negative 27 is not greater than negative 24, so I'm going to toss that one out, and the only one that actually works is 3 because that is greater than negative 24. Okay. Let's go ahead and take a look at another problem here. And this will be our last one for today. So this is example number 4. And then I'll let you guys try a practice one after that. Okay. So notice that we have subtraction here. So I'm going to be using the other property. But let's go into our domain. I think another interesting thing happens here that you'll be it'll be new to you. We set this greater than 0. I'm going to subtract 2. And we have x squared is greater than -2. Now, whenever you take a square root, something happens. You get 2 answers. You get a positive and you get a negative answer. That's not new. We've seen that before. But something else that we need to keep in mind is that this side's going to stay like that, x is greater than, and this other side, the arrow flips, x is less than. So it's kind of like when you have a divide by a negative. So you get 2 answers, but you flip the arrow on the negative one. But there's more to the story here other than that. It's possible that you'll have one that does this, and you'll have 2 domains you need to keep in mind. But this one has another interesting little thing to notice. Notice we're taking the square root of a negative. That's imaginary. And so a nice little note that maybe you want to add is the following. Since solving this gave me an imaginary number, that means there's no domain restrictions. When I'm trying to find out what are the restrictions on the domain, I end up with an imaginary answer. That means there's no real answer, which means there's no real domain restrictions. So if there are no domain restrictions, guess what that means? That means that x can be anything. So once I go through and solve this equation, whatever answer I get, that's the answer. I don't have to go back and check the domain because the domain has no restrictions on it. So we saw 2 interesting things on this problem. One is that when you solve an inequality with a square root, you get a plus and a minus answer. And the one that's minus, you flip the arrow. The other thing that we saw is that if you ever take the square root of a negative, you get imaginary. That means there are no domain restrictions, so x can be anything. All right, so we don't really need to worry about the domain, writing it down, because there is no domain restrictions here, so x can be anything. All right, so let's go ahead and move on to the next part, which is actually solving for x then. So since it's subtraction, we're going to do the property where you divide each of those pieces, which will look like that. Now this particular problem, we have to remember something that we saw from last class. There's the long way and the short way. The short way is just to notice, oh, they both have a log on both sides, so I can just cross it off. That's the fast way. But I mean, if you forget about that and you just think, oh, I need to exponentiate both sides, it doesn't matter. You'll still get the same answer because I'll show you. It still works. But if you want to just save yourself some time, when you have a log on both sides, you just cross it off. You don't really need to do this step per se. But these go away and these go away. And you're basically just left with x squared plus 2 over 9 equals 2. All right, so let's go ahead and solve it. We're going to multiply both sides by 9 because we have a denominator, right? That's what we do. We get rid of that denominator. So I get x squared plus 2 equals 18. Now this is a quadratic. Let's go ahead and solve it. I'm going to minus 18 on both sides. And I get x squared minus 16 equals 0. Now you have 2 different ways you could solve this. Actually, you have 3 ways. I'm going to go with the easiest way, but let's talk about the 3 ways you could solve it. Once again, you could do the quadratic formula. That's way overkill on this problem, but you could. The only thing is you have to know that your a is 1, your c is 16, and your b is not there, so it's 0. But you could do quadratic formula. It should give you an answer and it'll work. The other thing you could do is you could factor this doing the difference of squares. And then set each piece equal to 0 and solve. That'll work. Now, I want to show you a different way to do it, though, just because it's nice to review this stuff. This is when you have just an x squared, but not an x, Actually, the easiest way to solve is just to get the x by itself, in my opinion. I think it's even easier than factoring. You do need to remember, though, that when you solve by taking a square root, you get two answers. So there's a positive 4 and a negative 4. Now, on this one, I actually can keep both answers. Why? Because we saw that there are no domain restrictions, so both answers are good. Okay, so a couple of interesting things on this problem. We already talked about the domain part, but when you have a difference of squares, you can do quadratic formula, you can factor, or you can just get the x by itself. Whichever method you prefer is fine with me. Let's go ahead and have you guys see if there's one like that for you. So go ahead and pause this video. And give this one a try. When you unpause it, we'll have it worked out for you. All right, the answer is x equals plus and minus 18. Let's go through this and talk about some of the details here. So we have x squared needs to be greater than 0, which means you can have a positive and a negative, although positive 0 and negative 0 are really the same thing. But we still can do the arrow thing for the negative and for the positive there. And what this means is that x can be either less than 0 or greater than 0. So x can be either one of those things. But what it can't be is 0. Notice there's no room for that. So really there's only one thing that x is not allowed to be. It just can't be 0. It could be anything less than 0. It could be anything greater than 0. It just can't be 0. And neither one of my answers are that, so I get to keep both of them. But anyway, back to the problem here. Since we have subtraction, we can use the log property to rewrite it like this with one logarithm. Then we're going to exponentiate both sides, which cancels the log out on the left side, and on the right side we get 9 to the second power, which is 81. And then multiplying both sides by 4, we get 324 on the right, and the denominator's gone now on the left. And then we take a square root on both sides, plus and minus when you do that, by the way, which is 18. And there you guys have it. If you forgot how to take the square root of 324, well, you can use a calculator, or you could do the old method where you break it down into pieces. And basically just take out your pairs, right? You could take a 3 out, you could take a 3 out, and you could take a 2 out. 2 3s and a 2 makes 18. So that's the old way we did it without a calculator, or you can use a calculator. Either way is fine with me. Anyway, so that does it, and I think that's where we'll call it a day. So stretched you a little bit and expanded on our knowledge of how to solve log equations. Hope it was helpful, and we'll see you guys in class.